Section 7.1, Trigonometric Identities. There's not really anything new in this section. It's using a lot of the identities and things we've already gone over to simplify some expressions and verify some other properties. So let's just start by looking at examples. These are all of the identities that we've already gone over. We'll be referring back to them throughout the examples. So for our first example, we have cosine plus tangent times sine. The first thing that you really want to do is write everything in terms of sine and cosine. That's kind of our first trick, is make everything be sine and cosine. So let's rewrite tangent as sine and cosine. Tangent is sine over cosine. So if we rewrite this, we have cosine plus sine over cosine times sine. So since this is multiplying, you could say it's sine over 1, which would simplify to be sine times sine is sine squared over cosine. And this is plus cosine. To simplify, we should probably get a common denominator and try to combine these and see what we can get. So to get a common denominator, let's multiply, make the denominator be cosine. So multiply by cosine over cosine. So we get cosine times cosine is cosine squared over cosine. So now that we have them with common denominators, go ahead and combine them. So we get cosine squared plus sine squared over cosine. And from the Pythagorean identities, we can go back and look. Sine squared plus cosine squared equals 1. So sine squared plus cosine squared equals 1. So this is 1 over cosine. And 1 over cosine is secant. So all of that just simplifies to secant. For example 2, we're going to simplify sine over cosine plus cosine over 1 plus sine. So let's start, since we have two separate fractions, let's get a common denominator and combine the fractions. So to get a common denominator, we're going to multiply this one by cosine on top and bottom. And our first fraction will be multiplied by 1 plus sine. On top and bottom. So we have sine times 1 plus sine. Let's distribute. Sine times 1 is sine. Sine times sine is sine squared. And over here, cosine times cosine is cosine squared. We have a common denominator in cosine times 1 plus sine. So let's write that all together as one fraction. One plus sine times cosine. Our numerator, we have sine squared plus cosine squared, which from the Pythagorean identities we know is 1, so this is, our numerator simplifies to be sine of theta plus 1 over 1 plus sine of theta times cosine. Sine plus 1 is the same as 1 plus sine, so we can cancel. We just have a 1 on top, so it's 1 over cosine, which is secant. So next we're going to move on and talk about proving an identity. These problems are going to look like they're equations, but it's not the same as solving an equation. It's a little bit trickier. There's not a set of routine steps that you can follow through with. We have to use the identities that we know and substitute them on one side to make it identical to the other side. So we'll start with one side, use identities, and usually we'll just convert to sines and cosine. Sometimes you'll just make the left side of the equation look like the right side, and sometimes you might change them both a little bit to meet in the middle. So for this example, we have cosine times secant minus cosine equals sine squared. And we're asked to verify algebraically that it's an identity, as well as confirm graphically that it's an identity. So in order to confirm this graphically, you would just type the left side of the equation into your graphing calculator as y1, and the right side, sine squared of theta, just type that as y2. Graph them both and you should see that they are the exact same. So I'll leave that to you. But for part A, algebraically we can work it out. So let's go ahead and take this left side and let's distribute. We're just going to treat like we are simplifying this, but basically they give us the answer of what it should look like when we're done. So cosine times secant when we distribute, and cosine times cosine would be cosine squared. Secant is 1 over cosine. So we have cosine over 1 times 1 over cosine. So that would be cosine over cosine, which is just 1. So we have 1 minus cosine squared equals sine squared. And that's actually the Pythagorean identity just rewritten. If you add cosine squared to the right, we'd have 1 equals sine squared plus cosine squared, which is true. That's the Pythagorean identity. So we're actually done right here at this step. This filled in box is common notation, just showing that you're done showing what it was you were asked to do. So we're actually finished right here. You just look at the left side. We get 1 minus cosine squared, which is sine squared, so we are done. So here's another one. We're going to verify that 2 tangent times secant equals 1 over 1 minus sine minus 1 over 1 plus sine. So to simplify this one, we're actually going to look at both sides, and this is going to be one of those where So we're going to meet in the middle. So we're going to work the left side over here. And we'll work the right side over here. And we'll show that down here below, they do equal the same thing. So first, let's take the left side and let's rewrite it with only sines and cosines. So we have a 2. Tangent is sine over cosine. And secant is 1 over cosine. Since this is all multiplication, this would actually become 2 sine on top over cosine squared. And then let's go ahead and look at the right side of the equation now. Let's do some work over there. So since we have 2 fractions, we are going to combine them by getting a common denominator. So this one needs to be multiplied by 1 plus sine on top and bottom. And multiplied by 1 minus sine on top and bottom on this side. So we get 1 plus sine of x minus 1 minus sine of x over 1 plus sine of x times 1 minus sine of x. So we need to FOIL. 1 times 1 is 1. Sine times 1 is sine. 1 times negative sine is negative sine. And sine times negative sine is negative sine squared. So that's our common denominator, multiplied out. Sine minus sine, obviously those will cancel. So it's really just 1 minus sine squared for our denominator. Our numerator, we can add the opposite. So we have 1 minus 1 is 0. Sine plus sine is 2 sine. So now we can see that our numerators are at the top. So now we just need to check and see if cosine squared equals 1 minus sine squared, which is, it does, from the Pythagorean identity. So we're going to use the sine squared plus cosine squared equals 1. And if you solve it for cosine, you get cosine squared equals 1 minus sine squared. So replace our denominator, 1 minus sine squared, with cosine squared. And now we show that the left side equals the right side. So we're done. For this example, it's a little bit different because we're going to take the left side of the equation. And in order to simplify, we're actually going to, as the directions indicate, we're going to introduce something extra, meaning we're actually going to multiply what we have by something to, it will eventually make it more simplified, but for the time being it actually looks a little bit more complicated. So we're going to multiply, similar to what we did in the last example, by 1 plus sine of u. On top and bottom, so we get cosine of u plus cosine of u times sine of u over, and when you FOIL this out like we did in the previous example, you get 1 minus sine squared, which we also know is that's cosine squared. So the cosine squared on the bottom, and there's a cosine on the top in each part that we can cancel out with it. So one of the cosines on the bottom cancels out cosine in both parts on top. Or if we went to distribute it, it might be a little bit easier to see that cosine cancels one of those. And we'd just be left with 1 plus sine of u over cosine. Now we can take this fraction, and since it's addition on top, you can split it up to be 1 over cosine plus sine over cosine. And you should recognize 1 over cosine as secant, and sine over cosine as tangent. That's what we were supposed to show that it equaled. We just did. We're done. For this example, we're going to work each side separately again. So let's go ahead and take a look at the left-hand side. We have 1 plus cosine of theta over cosine of theta, which, since the addition is on top, we can split the fraction into 2 fractions. So we have 1 over cosine plus cosine over cosine. 1 over cosine is secant, and cosine over cosine is 1, so this is just secant plus 1. On the right-hand side, we have tangent squared over secant minus 1. If we go all the way back and look at our identities, there's a Pythagorean identity with tangent squared and secant squared. So let's go ahead and take this Pythagorean identity and replace tangent squared with secant squared minus 1. Tangent squared, replace that with secant squared minus 1 over secant minus 1. Secant squared minus 1 can actually be factored. If you think about it as like a x squared minus 1, that would be x plus 1, x minus 1. It's a difference of squares. So that means our numerator here can factor to be secant plus 1 times secant minus 1 over secant minus 1. So our secant of theta minus 1 cancels on top and bottom. So we're left with secant of theta plus 1 equals secant of theta plus 1. Done. So for our last example, we're going to do what they call trig substitution. And that's where you substitute a trig function in for a variable to simplify and make it a little bit easier. So if we replace x with sine of theta, 1 minus x squared would become 1 minus sine squared. And we know from the Pythagorean identities, sine squared plus cosine squared equals 1, which means cosine squared equals 1 minus sine squared. So instead of writing 1 minus sine squared, we can substitute cosine squared. And now it's just one thing that we can take the square root of. So the square root of cosine squared would just be cosine. This is a method that actually helps a lot when you get into calculus to use this trick several times.